Hello guys, welcome to our channel Civil Engineers. In this lecture, we are going to solve one problem of spring element. Here's our diagram. In this diagram, we have four nodes U1, U2, U3 and U4. U1 and U4 are at the fixed end and U2 and U3 are at the connections of the springs. The values are given. We need to find out the global stiffness matrix. For that, first we have to find out the local stiffness matrix for all the elements or springs K1, K2 and K3. Global stiffness matrix is nothing but the combination of local stiffness matrices of all the elements. So let's start the solution. The formula for local stiffness matrix for a spring element is, for K1 it is K1 minus K1 minus K1 and K1. Put the values 100 minus 100 minus 100 and 100. And again for K2 it is same. So let's put the values directly. K3 is 300 minus 300 minus 300 and 300. The next step will be determining the global stiffness matrix. There is a trick to write the global stiffness matrix. First of all, write down the values of K1 means 100 minus 100 minus 100 100 plus the first element of K2 minus 200 and then minus 200 200 again first element of K3, okay, minus 300 and 300. The rest of the elements will be 0 and 0. Solve it. It comes out to be 100 minus 100 0 0 minus 100 300 minus 200 0 0 minus 200 500 minus 300 0 0 minus 300 and 300. So this is our global stiffness matrix. Now we know stiffness matrix into U means displacement at nodes equal to force at nodes. Write down the global stiffness matrix, that is 100 minus 100 0 0 minus 100 300 minus 200 0 0 minus 200 500 minus 300 0 0 minus 300 and 300 into nodes. Write it as it is. The nodes are U1, U2, U3 and U4. Okay, equal to, in case of force at nodes, we have tensile force at U1, tensile force at U2, compressive force at U4, the force at U3 is given. As there is no force at U2, it will be 0 and rest will be unknown. So we found force at U1, 0 at U2, 400 at U3 and force at U4. So our next important step is applying boundary condition. Please observe the diagram. There are fixed ends at U1 and U4. So there will be no displacement due to any force, right? So U1 and U4 is 0. Therefore this complete row and this column and this row and this column will become 0. Now the remaining elements of K is 300, minus 200, minus 200 and 500. Displacement at 2, displacement at 3, 0 and 400. Now we can form two equations out of it. 300 into U2 minus 200 into U3 equal to 0. Minus 200 into U2 plus 500 into U3 equal to 400. Equation 1 and equation 2. So let's solve it. Multiply equation 1 with 2 equal to 600 U2 minus 400 U3 equal to 0. Equation 2 with 3 is minus 600 U2 plus 1500 U3 equal to 1200. And now adding these two equations, what we found is plus 600 U2 and minus 600 U2 will be cancelled out, and this will be 1100 U3 equal to 1200. So U3 will become, just calculate it, it is 1.09. and now put the value of U3 in equation 1. So equation 1 will be 300 U2 minus 200 into 1.09 equal to 0. So ultimately U2 will become calculate it. It is 0.72. And these are the final values of displacement at node 2 and node 3. Thanks for watching. Comment down below if you have any doubt and let me know likes and dislikes about the video.